Every year, somewhere in the North Sea, a structure the size of a skyscraper quietly disappears. Not from a storm, not from an accident. It is taken apart, deliberately, carefully, piece by piece, and brought back to shore. These are offshore oil platforms. Some of them have stood in freezing waters for over 40 years. They weigh tens of thousands of tons. They are held together by steel legs driven deep into the seabed. And when their oil runs out, someone has to deal with them. For decades, the world had no real answer for that problem. But Norway did something different. Instead of abandoning these giants at sea or sinking them, Norway built an entire industry around taking them apart. And in doing so, they discovered something unexpected. Hidden inside these rusting structures was a fortune. Rare metals, precision machinery, hundreds of kilometers of copper wiring, equipment worth millions, sometimes tens of millions, per platform. Equipment that could be cleaned, tested, and sold again. But recovering it was not simple. It was not safe. And the methods required to do it had never really been tried at this scale before. So how did Norway figure it out? And what exactly have they been pulling out of the North Sea all this time? The North Sea is not a forgiving place. Winds can hit 150 kilometers per hour. Waves reach the height of 6-story buildings. Temperatures drop low enough to kill an exposed man in minutes. And yet, for over half a century, Norway planted steel structures out there, massive, towering platforms, and pulled oil from the seabed beneath them. At its peak, Norway had over 500 offshore installations operating across its continental shelf. They powered economies. They funded hospitals, roads, and schools. Norway became one of the wealthiest nations on Earth largely because of what those platforms pulled up from below. But oil fields don't last forever. By the late 1990s, some of Norway's oldest platforms were running dry. The oil was gone. The platforms were aging. And the companies that owned them faced a question nobody had seriously planned for. What do you do with a 30,000-ton steel structure sitting in the middle of the ocean? Early proposals were alarming. Some operators suggested simply leaving them in place, letting the sea slowly consume them. Others considered towing them into deep water and sinking them entirely. Then, in 1995, Shell proposed doing exactly that with one of its platforms, the Brent Spar in the North Atlantic. The public reaction was fierce. Environmental groups mobilized across Europe. Protests erupted at petrol stations. The story dominated headlines for months. And under that pressure, something shifted inside the Norwegian government. If platforms couldn't be abandoned and couldn't be sunk, then they had to be brought back to shore. But nobody had ever done that before. Not at this size. Not in these conditions. And the engineers who first looked at the problem said the same thing. It might not even be possible. First serious attempt to dismantle a large North Sea platform happened in the early 2000s. Engineers quickly realized that removing an offshore structure was almost as complex as building one. The platforms weren't just sitting on the water. They were anchored to the seabed by massive steel legs, some driven 80 meters into the ocean floor. Cutting those legs underwater, in the dark, in freezing currents, required technology that barely existed at the time. Special vessels had to be designed. Heavy-lift ships capable of carrying tens of thousands of tons were commissioned. Underwater cutting tools were developed specifically for this work. The costs were staggering. Decommissioning a single large platform could run to $500 million or more. Norwegian authorities and oil companies began negotiating who would pay. The government had strict regulations. Platforms could not simply be left to rust. Operators were legally responsible for removing what they had installed. But here is where something unexpected entered the picture. As the first platforms were brought ashore and workers began stripping them down, they started finding things, not just scrap steel. Inside the modules, the enclosed sections where workers once lived and operated machinery, there were components that had barely been used. Pumps, compressors, valves, control systems. Some of this equipment had been installed, run for a few years, and then left idle as production slowed. It was still functional. A decommissioning supervisor working at the Kerner yard in Stord made a quiet observation in a project report around this time. The equipment coming off these platforms wasn't garbage. Some of it was worth more than the steel around it. The question was, could it actually be recovered, certified, and sold again? Nobody had tried. Nobody had a system for it. Yet, the yard at Stord on Norway's southwestern coast became ground zero for something nobody had officially planned. Workers dismantling the first major platforms began setting components aside, not for scrap, for inspection. Valves the size of car engines, heat exchangers, electrical switchgear, hydraulic systems that had spent decades sealed inside pressurized modules, protected from the salt air outside. When engineers examined them, they were surprised. The corrosion was on the outside of the platforms, on the exposed steel. But inside the living quarters and equipment rooms, conditions had been controlled, heated, maintained. Some components were in near original condition. Word spread quietly through the industry. A small number of specialist companies began emerging, firms that did nothing but assess, clean, test, and certify recovered offshore equipment. The process was meticulous. Each component had to be traced back through maintenance records. Every hour of operation had to be accounted for. Pressure ratings had to be verified. Materials had to be tested. It was slow. It was expensive. But the numbers started making sense. A new subsea valve could cost $400,000. A recovered, certified version of the same valve from a platform being scrapped could sell for a fraction of that price. And buyers existed. Smaller operators, emerging markets, companies running older fields that needed affordable parts. By the mid-2000s, this quiet recovery operation had a name. The industry called it asset recovery, and Norway was doing it better than anyone else on Earth. But then came a discovery that changed the scale of everything. Engineers working on one of the larger Ekofisk area platforms pulled out a set of subsea control modules. Still sealed, still pressurized, never opened since installation. What they found inside stopped the project for 3 days. The modules had been installed in the early 1980s. At that time, subsea control technology was cutting edge. The components inside were precision engineered. built to tolerances that were difficult to manufacture, even by modern standards. When engineers cracked the seals and examined the contents, they found instrumentation that was not just functional, it was exceptional. Sensors, measurement devices, control units. Some of them used materials and construction methods that had since become harder to source. Certain alloys, specific configurations of internal components. The team brought in a specialist, a retired instrumentation engineer who had worked on North Sea installations since the 1970s. He examined the recovered units for 2 days. His assessment was direct. These components, properly recertified, were more reliable than some modern equivalents. They had been built in an era when offshore equipment was over-engineered by design. Safety margins were wider. Materials were denser. The modules were sold, not for scrap weight, for operational use. They went to an operator running a platform off the coast of West Africa, installed, tested, running within months. That single recovery from one set of modules on one platform brought in $4.2 million. The platform's total scrap steel value had been estimated at around $8 million. In other words, components taking up a fraction of the platform's volume were worth more than half the weight of the entire structure. The industry quietly recalculated everything. Every platform scheduled for decommissioning now had a different kind of value assessment attached to it. Not just, what does the steel weigh, but what is still alive inside this thing? The answer, in platform after platform, was more than anyone had expected. But recovering it came with a risk that nobody had publicly discussed. Offshore platforms are not clean structures. Decades of oil production leave residue in pipework, in tanks, in the walls of modules. Some platforms carried low-level, naturally occurring radioactive material, deposited by produced water over decades of operation. Dismantling them required strict protocols. Workers needed specialist training. Certain sections had to be isolated. Some materials had to be processed as hazardous waste before anything else could happen. This added cost. It added time. But Norway had built regulatory frameworks specifically for this. The Norwegian Oil and Gas Association worked alongside the Environment Agency to create standards that no other country had developed at this level. Every platform entering decommissioning had to be assessed, mapped, and cleared before asset recovery could begin. It was meticulous work, and it made Norwegian yards uniquely capable of handling what other nations could not. By 2020, Norway had decommissioned dozens of major offshore structures. The asset recovery industry had matured into a recognized sector with dedicated facilities, trained engineers, and international clients. The IM platform, the Ekofisk Bravo jacket, the Frigg field structures, each one yielded materials, equipment, and components that re-entered the global supply chain. The total value recovered across Norway's decommissioning program runs into the hundreds of millions of dollars. And there is more to come. Over 100 additional Norwegian offshore structures are scheduled for decommissioning before 2040. Each one is, in a sense, a warehouse. A warehouse that was sealed decades ago, filled with precision equipment, and left sitting in the North Sea, waiting. Norway figured out how to open those warehouses, And what they're finding inside is rewriting the economics of an entire industry. If this story made you think differently about what we throw away and what might still be worth saving, subscribe for more documentaries that go beneath the surface.